Hi everyone, we're starting our next unit on expansion and different forms of expansion. We'll be looking in the MYP4 book in Chapter 3 and also in the MYP5 Plus book we'll be looking at Chapter 2. Alright, so let's get started very quickly. Some of these things you will already have done. You will have seen most of these things from last year, I'm assuming, so this should not be a very long lesson at all. So we're going to be looking at three separate sections today. The first one we're going to look at is in algebraic expansion and simplification. We're going to be looking at just collecting like terms. So we should all know by now that, for example, AB and 2AB are considered like terms because AB and AB have the same variables on them. If I were to look at x and xy, those would be considered unlike terms. It means that I would not be able to either add them or subtract them. So we can simplify algebraic expressions by adding or subtracting like terms. So we cannot add or subtract unlike terms. Now if we want to just take a quick look at this table, so we know that 4x and 3 are not like terms. Okay? They are both considered monomials, but they are not like terms. One of them has no variable. The 3 has no variable on it. The first one does, 4x, x being the variable. The second example, 4x and 3y, they're not considered like terms either, simply because x and y don't have the same variable. It doesn't matter what the actual coefficient is, the 4 and the 3, as long as the variables are the same, then we can add them or subtract them. Now, if we look again at a third example, 4x and 3x squared, again, x and x squared are not like terms. They have the same variable x, but they don't have the same degree. The degree always refers to the power. One of them has a power of 1, the other one has a power of 2. So that means that they cannot be added or subtracted together because we don't have like terms. Now if I look at 4x and 3x, well, the x and the x are the same here, and therefore we know that we can add them together or subtract them depending on what the question is asking. Alright, so if we were to do very quickly 3x plus 4x, that means that I would add together my coefficients, 3 plus 4, which gives us 7, and x just stays as x. We do not put it as x squared or 2x or anything. When I am adding like terms, I only add the coefficients in the front together, and the values of the x's, y's, and z's, whatever they may be, will remain as they are. So my point being that if I have x plus x, that will go to 1x plus 1x, which is 2x. It does not equal 2x squared. Absolutely not. The answer is just 2x. If we want to take a look at the next example, 2x squared minus 3x minus 4 minus x squared plus x plus 9. Again, my tendency would be at this point to bring together all the like terms. So I would say 2x squared minus x squared minus 3x plus x minus 4 plus 9, so that I have x squared minus 2x and then plus 5. And that would be my final answer there. Okay, so again, I just collected my like terms and I added or subtracted the coefficients in front of them depending on what the symbol is in the front. Alright, so if I were to simplify the next example, again, we're just going to do some simplification of a few examples. Again, I'm going to bring together my like terms. So 10x cubed minus 4x cubed minus 14x squared. And there is no other x squared, so I move to the next one, which is plus 3x plus 4x and then minus 6. So 10x cubed minus 4x cubed will give me 6x cubed. So I'll put that here. Well, that will give me 6x cubed. And then negative 14x squared is just negative 14x squared because there is no other x squared. And 3 plus 4 will give me plus 7x. The coefficients are the same. We add the coefficients and we have the same variable, and then minus 6. My next example, 10a minus 3a will give me a 7a, and 2ab plus 5ab will give me plus 7ab. So again, we're always looking at collecting like terms. Now, here I have just in huge writing exactly what I mentioned to you before. If I am doing x plus x, so it's right here, if I'm doing x plus x, then I am saying that I am just going to add. So I have 1x plus 1x gives me 2x. It does not become 2x squared. It doesn't become x squared. It doesn't become anything of the sort. But if I have multiplication going on, x times x, then if you remember the laws of the indices, which tells us a to the m times a to the n will give us a to the m plus n. So that means that we would add together our exponents, and 1 plus 1 would take us to 2. Okay, so if we have something like x cubed plus x squared, we cannot do anything with that. The answer would just remain as is. It's not going to be x to the 5th, it's not going to be 5x, it's not going to be anything of the sort. It'll just be x cubed plus x squared. If we have 2x plus x, the answer is just going to be 3x here. It's not going to be 2x squared, because that would be 2x times x would give me 2x squared. Okay? All right. Moving on. So if we're looking at algebraic products, again, we've already done this when we worked on the indices in Chapter 2, but I think it's always worthwhile just reviewing this. So what we do is we want to multiply when we are doing algebraic products. So if it's products, we're referring to multiplication of terms. Okay, so that if I've got negative 4x multiplied by, so that little dot there means multiplied. If I've got negative 4x times 3x cubed, we are going to multiply our coefficients together so that we'll have negative 12, and then x to the power of 1 times x to the power of 3 will give me x to the power of 4. There's my final answer, negative 12x to the 4th. Okay, so if I want to take a look at the next one, I've got 2a squared b times negative 6a to the power of 1, b to the power of 2c. So 2 times negative 6 will give me negative 12. A squared times a to the power of 1 gives me a cubed. B to the power of 1 times b squared will give me b cubed as well. And then I only have a c left over, which is really c to the power of 1. Now, if I take a look at my next example, let's see what we can do with that. This is going to be 2x squared times 3y minus, there's a minus here, 5x squared times 2y. Remembering our order of operations, so 2x squared times 3y would give us 6x squared y. And then this would be 5 times 2 is 10, it's minus 10x squared y. Because it's x squared y all along here, x squared y and x squared y, then that means it's 6 minus 10, which is negative 4x squared y. Okay, now section 3c. So we've taken care already of section 3a to 3b. We're going to very quickly take a look at section 3c. 3c is the distributive property. You all know already how to do the distributive property. It's really a form of expansion, and when we are expanding, it means that we are taking away brackets or parentheses. We are removing parentheses when we expand. So if I have a times bracket b plus c, in order to remove that parentheses, that everything outside of the parentheses that is multiplied to that parentheses has to be multiplied with everything inside the parentheses, so that I have a times b gives me ab, and a times c gives me ac. So that would be my first example. Next one, if I have negative 3 times bracket a minus 5, it's negative 3 times a, and negative 3 times negative 5. So it goes to negative 3a plus 15. Then 2x times x minus a will give me 2x squared minus 2ax, or 2xa. But we usually place the letters in alphabetical order. So we don't tend to say 2xa, but 2ax. If I want to do the last example here, it's a times 2 is 2a, a times negative b is negative ab, and a times c is positive ac. There's nothing else that can be simplified here because none of the variables are the same. A, ab, and ac are three different variables. Therefore, I can't add or subtract anything here. So every term in the parentheses has to be multiplied by whatever is outside of the parentheses, which is multiplied to it. All right, so let's just do a couple of other examples, and that pretty much covers this section of sections 3a, b, and c. So we're going to very quickly do 2x times 3x is 6x squared. 2x minus 7 will give me negative 14x. And that'll be minus, now it's minus 4x times 2, which is negative 8x. And then negative 4x times negative 3x gives me positive 12x squared. Okay, so that's something that you need to be careful about. And then it's plus x times x is x squared, and x times 2 is 2x. So I now collect my like terms so that I have 6x squared plus 12x squared minus plus x squared minus 14x minus 8x plus 2x, and that ends up giving me 18 plus 1 is 19, so we've got 19x squared minus 14x minus 8x gives me negative 22. Negative 22x plus 2x gives me negative 20x. So there's my final answer. Now, here's a case where many students tend to forget here, is that when I have a negative in front of a parentheses, that's as if I were multiplying by negative 1. I'll just put that in red. It's like as if I were multiplying by negative 1. So that means that negative 1 times 3x is really like saying negative 3x, and negative 1 times negative 7 is like saying positive 7. So the moral of the story is basically that if you have a negative outside of a parentheses, so minus 5 plus x, for example, all you need to do, as soon as you see the negative on the outside, you automatically know that you're going to be changing the signs of everything within the parentheses in order to get rid of that parentheses. So that this would go to 5 minus x. A negative times a negative goes to a positive 5, and a negative times a positive goes to a negative x. All right, let's take a look at the next examples, so that we have negative 6a plus 12 minus 3a plus 2. And that ends up giving us negative 9a plus 14 by bringing together our like terms. Let's look at one more example here. We've got 2x times x gives us 2x squared minus 14x. And then it's minus 2x squared. And again, it's a negative times a negative, which gives us a positive 3x there. So that's another thing that students tend to forget right here, is that they always say it's negative x times 2x, and they put that as negative 2x squared, and then they forget that they also still have to do the negative x times negative 3 for the second half of that, so that it also changes the signs there. So that our final answer then in this question would turn out to be 2x squared minus 2x squared cancels itself out. Negative 14x plus 3x gives us negative 11x. All right. The very last section we're looking at today is found in section 3D, and it's using FOIL. Okay, so FOIL, what we're basically doing is we're doing an extension of the distributive property, except instead of multiplying one term by something inside a parentheses, we're multiplying two parentheses together. So, for example, if I've got a plus b, plus, I'm just going to redo this again. So if I've got a plus b and it's multiplied by c plus d, and it's multiplied by c plus d, what it's basically telling you is that every term in the first parentheses has to get multiplied by every term in the second parentheses. So I will do the first terms, a times c gives me ac. Then I'll do the first term with the last term, or a times d, which is ad. Then I do the second term of my first parentheses with the first term of my second parentheses, which gives me bc. And then b times d is my last one, plus bd. Now, all this is called really is FOIL. And what that means is you do your first terms, you multiply your first terms, then you multiply your outer terms, you multiply the inner terms together, and then you multiply the last terms together in each parentheses. So if I wanted to do the next example here, I would do my first terms, 3x times 1 is 3x. Then I would do my outer terms, the ones that on the extremes, on the totally left and totally right. So 3x times 2x is 6x squared. Then I would do my inner terms, negative 2 times 1 is negative 2. And then my last terms in each, negative 2 times 2x is negative 4x. So that I would say, so I would say 3x minus 4x is equal to negative x, and I still have a 6x squared, and I still have a minus 2. Now, before I continue, let me just state that normally when we are writing out our solutions, we are always going to go from our highest degrees of the x's or y's or z's to the smallest degree, to the no degree. So we would go from x cubed to x squared to x to the power of 1 to whatever the constant is. So because x squared was the highest degree here, then it went from x squared to x to the constant. Let's take a look at the next one. 2 times 5 is 10. 2 times x is 2x. Negative 3x times 5 is negative 15x. And negative 3x plus times x is negative 3x squared. So now, putting them in the correct order, it would be from the largest degree, negative 3x squared, minus 13x, negative 15 plus 2 is negative 13x, and then plus 10. Okay, and then we're almost done here. Now, if we're going to be working out this problem, I would leave the negative out for the moment first. Okay? Because I have this negative on the outside, I would leave it on the outside, and I would just FOIL what's on the inside first. So 2x times 4 is 8x. 2x times negative x is negative 2x squared. 3 times 4 is 12. And 3 times negative x is negative 3x. I would then simplify, leave the negative still on the outside, so that I have 8x minus 3x is 5x minus 2x squared plus 12. And now, because I have the negative in the front, I can in front of that parentheses, I can change all the signs inside the parentheses in order to remove the parentheses. Remember, it's like as if I had a negative 1 in the front there. And that's everything is getting multiplied by negative 1. So that this goes to negative 5x plus 2x squared plus 2x squared, and it's minus 12. And then, of course, I'm going to put it in the correct order of 2x squared minus 5x minus 12. Okay, that's it. When we're in class, we're going to go over a number of questions from this website, Mathopolis, where you can do 10 questions from the website. All right, the work that you'll be doing in class, or for homework, because I'll probably be teaching this in class tomorrow, is found on the next page. So I'll see you next time.